Bismillah ar-Rahman ar-Rahim. This is our project presentation, rear car sensor system. Here's the outline. I'm going through these headlines one by one, from the introduction, hardware architecture, software, project components and integration till the end, which is problem faced. As a start, we wanted to build a simple version of any rear car sensor system. This system is off by default, so the system will start working when clicked on by a switch. We provide three stages or three states called green, yellow, red, which represent how close the detected object is from our sensor or from the whole system. Also, some requirements we include is that should be cheap in cost, and the power needed is 5 voltage. This diagram shows how the embedded system works in hardware point of view. We have the CPU and memory, and both are inside the microcontroller, and they are connected to a shared bus. As we click on to start the system, the data comes from the ultrasonic and go to the shared bus till reaching the output devices, which are display and alarm buzzer or buzzer alarm. This is the software architecture. Here, once we click on the switch, we get the distance and we get the current state. This data that we get the distance from the ultrasonic, but by calculation we determine the current state according to the distance. So this information or this data goes to the output or the display screen and goes to the buzzer to make the proper sound for each stage. And every 1 microsecond, it will be this data will be updated if the distance has changed, or it is or it keep the data or the distance the same and the stage the same if no changes. The components we used to build the rear car sensor system are as follows. We have our microcontroller ARM Mbed LBC 1768. We used 3-band ultrasonic for distance sensor, which is called Bing. We have our LCD 16x2 character, which give 16 character in 2 lines, and we have the piezo buzzer, which give some sound or some alarm for each stage. Some problems we have encountered during working on this system is for ultrasonic. When writing the code that uses the ultrasonic echo and trig functionalities to get the distance, we got random numbers that does not match the real distance. After doing some research, we found an equation that converts the time that we get from the timer to distance in centimeter. For the character LCD problems, we have faced two problems. One is when connecting the pins of LCD and writing some code for printing, we did not get any printing. The LCD was working, but no characters displayed. So we did some research and we found that we need another component to control the contrast of LCD, the dots that make the characters we print. Also, another faced issue was when controlling the RGB LED of the LCD, the colors. The problem was that the pins of RGB LED are active low, which we did not figure it out from the beginning. So after asking our instructor, Dr. Hazem, about that, he informed us that the RGB LED must be defined as output and considered as active low. Thank you for listening. This is the end of the presentation.